Now feel free to choose anything you want. We have problems from 1 through 62, but for now we are focusing on indefinite, and then we will look at definite. So right now we choose from 1 through 44.
We do fruitful.
Yes, you can tell me more than one, and I'll write them here, and we'll look at them. All numbers. I'm going to write all numbers you want to choose. I'm ready.
9, 4.
9. The other one?
44.
You said 44?
Yeah.
Okay, 44. Anything else? Okay, so we want to start with 9. So let's start with 9. 9 is the indefinite integral from natural log x to the 7th power divided by x dx. Of course, x greater than 0. Perfect. So now let's look at all pieces that we see. I see how many pieces? I see a natural log to the power 7. I see x in the denominator, and I see dx. Nobody can touch this. There is nothing I can do to poor x. So can anyone suggest a substitution? You may start with a substitution and then realize that is not the right one, and you go back and try another. But try something. What will you say? Let y be anyone, please? Give it a shot. It's okay if you're wrong. What will you denote by y? Anyone? Any suggestions? Well, the obvious suggestion is natural log x, because I don't like natural log x to be raised to the 7th power. Good. Can anyone give us the differential of this function? Without the differential, we cannot continue. That's the reason why I started with this, with the differential. Can anyone give us the differential of natural log x?
Would it be 1 over x?
The differential. You only gave me the derivative. We need the differential, not the derivative. Anybody try again? So it's 1 over x dx. Is this in the problem? Yes, here it is. This is my dy. And this will be y to the 7th. So therefore, the integral is very easy again. Y to the 7th dy. So this is our y to the 7th, and dx over x is our dy. So therefore, y to the 8th over 8 plus a constant c. All I have to do is replace y by natural log x. And that's it. Any questions on number 9? Okay, let's look at 44. '44 is slightly different. And you'll see in a minute why. So, of course, we have to practice as on as many functions and integrals as possible. So, the problem here is not the numerator. In both situations from before, The problem was here because it has power 5. Same thing here. The problem was here because it had power 7, mainly. Now, the problem with such a function is actually the denominator. This is the problem. Why? So every time I have, let's say, whatever polynomial divided by one term, I can always separate into fractions. I can simplify it somehow. But if I have x plus 1, I can't do that. So this is the problem. When the denominator has 2 or more terms. So in this case, I have to try y equals 3 plus e to negative x. As long as I can find dy. And somehow dy is in the problem. Maybe hidden a little bit, but it's there. Can anyone give us the dy for this function? Please? You know I don't like to waste time. Anybody, please, would like to give us dy? Can anyone differentiate this function?
Would it be e to the negative x dx?
But e to negative x prime is e to negative x times the inner function prime. So negative e to negative x times dx. Good. So I have the denominator, which is y. I have that 4 in the numerator. I don't care about it. I really don't. It can go outside because it's a factor. So now I need negative e to negative x dx. Not a problem. What I'm going to do, I'm going to multiply by negative 1 twice. Multiply by negative 1 twice is not going to change anything. But now I have to keep this negative in front. And the negative with e to negative x and dx, negative 1, e to negative x and dx, these make up the dy. And the denominator is y. So let's do this one more time. I realized that I had e to negative x. I realized that I had the product e to negative negative x dx. It's right here. But I was missing this negative sign. Okay. Negative 1 times negative 1 is 1. So I'm not changing anything if I multiply by negative 1 twice. But I need this negative 1 to be incorporated with or put together with e to negative x and dx. Because these 3 pieces make the dy. The 4 can go outside and stay patiently waiting with a negative sign in front. And the denominator is what we denoted by y. Now the next question is, which function prime is 1 over y? Anyone remembers which function we differentiate to get 1 over y? Which function we differentiate to get 1 over y, please? Anyone? So that is a natural log of the absolute value of y plus a constant c. I have to go back and replace. Since this is positive and this is positive, I no longer need the absolute value bars on y. So negative 4 natural log parentheses 3 plus e to negative x plus a constant c. So what have we learned from this example? The denominator with 2 or more terms is a problem. What else we learned? We learned that we can always make up a sign or a number. I multiply by -1 twice. Or you can say, we multiply by -1 and divide by -1. It's the same thing. How will I check something like this? When you differentiate this, you have to get this function, 4e to -x over 3 plus e to -x. Let me know if you want us to check the answer. If not, we'll move on. Okay. Anything else we would like to look at, please? Before we look at definite integrals. Okay, I will pick another fraction like 19. In 19, we have the integral from 1 over 5 plus 2x dx. Of course, x cannot equal -5/2, obviously. Good. So what do I do? Well, exactly the same thing. This is the problem. So I'm going to say, let y be 5 plus 2x. Can anyone give us dy for this function? Please say something. Anybody, please? Can anyone give us dy for this function?
Would it be 1/2 over d of x? Or
We're not integrating, we're differentiating.
2 dx.
2 dx. Very good, thank you. So I have the dx, but I don't have the 2. No problems at all. Multiply by 2 and divide by 2. When I multiply by 2 and divide by 2, I haven't changed anything because this is 1. But now I have the dy, and that was my purpose. And I leave the 1/2 outside. Patiently waiting. So the integral from, again, dy over y. So this is 1/2. Again, which function prime is 1 over y? We just had that a minute ago. Anybody?
Absolute value.
Natural log of the absolute value of y. Very good. Plus a constant c. All I have to do, now I cannot remove the absolute value because this is positive, but this could be negative. And the answer could be negative. So I cannot remove the absolute value bars on this, like I did on the previous problem. They have to stay. Any questions on this? Again, what have we learned from this? We learned that we can always make up a constant, not only a negative sign if we need to, but we can always make up a constant. Multiplying and dividing by 2 does not change anything. Good. Do you think we need more examples? If you say yes, let's choose. If not, I'd like to move on to definite integrals. Do we need more examples? Maybe we want to choose one with a radical, like 41, 42. Okay, let's look at 41. Do you want to choose something else? Okay, I know it's Thursday. I know you're tired, but please talk to me. Okay, looking at this function, I see a piece here and I see a piece here. Any suggestions about the substitution? Always remember, we use the substitution, we simplify the integral, we get the answer, but we always have to go back to the original variable. This integral had x, was given in x, the final answer has to be given in x as well. Can anyone suggest a substitution here? It's okay if you're wrong.
Would it be the square root of 1 minus x squared?
Just the 1 minus x squared.
Oh.
Very good. Perfect. Can anyone give us the dy for this problem, for this function, for this y?
2x dx.
Yes, but negative. Excellent. Indeed, negative 2x dx, because negative x squared prime is negative 2x times dx. Excellent. Good. So, dx is dx. X is x. So this piece and this piece. I don't have the negative 2. No big deal. Multiply by negative 2 and divide by negative 2. That will never hurt, will never hurt anybody, and it's just 1. If I multiply by negative 2 and divide by negative 2, I haven't changed anything. But this is what I need, because negative 2 times x times dx, these three pieces, this, and this, will change into dy. So I have a negative 1/2 outside. I have the integral from a 5. I'll also take it outside. So I have the negative 2x and dx, that's dy. How do I write this? Knowing that under the root, I have y. How do I write the 4th root of y? What is the convenient way of writing the 4th root of y? Y to which power?
One over 4.
Excellent. Thank you. Before we continue, do we understand the step from here? It's okay if you say no. I'll repeat the steps. Okay. You can always say no later on. So y to 1/4 plus 1, which is 5/4, over 5/4 plus a constant c. I copy negative 5/2. I flip 4 over 5. And y, I have to go back to 1 minus x squared raised to 5/4 plus a constant c. I will simplify these. I will simplify these. So the final simplified form will be negative 2 1 minus x squared raised to 5/4 plus a constant c. I know that this is not enough. We need a lot of work. If you practice, if you want to choose something else, feel free. Maybe we should also look at some one with e. Would you like to choose one with e? We had fractions, we had natural log, we had radicals. So now let's look at one more with e, from 11 through 18. And then we'll, which one?
18.
18, very good. Good. 18, so the integral from t e raised to negative t squared dt. By now I think you're getting a hang of this. So let y be, what do you think? What would you pick? Even if it's wrong, just tell me what would you pick. What do you think? What would you pick? What bothers you from what you see here? T cannot bother you, dt cannot bother you, e cannot bother you. So then what is possible?
Would be t squared.
Negative t squared, indeed. Yes, that's what bothers me too. So can anyone give us dy? Because without dy, we can't continue. Can anyone determine dy for this function?
Negative 2t dx.
Very good. dt. Good. Because it's t, I have to write dt. Perfect. Excellent. So I have the t. I have the dt. I'm missing a negative 2. Piece of cake. Negative 2 multiplied by negative 2 and divided by negative 2. Now I have all three pieces. I have the negative 2, I have the t, and I have the dt. All these change into dy. And this will change into e to y. So, negative 1/2 in front, the integral from e to y dy. The substitution is supposed to change a complicated integral into a very simple one. So this is negative 1/2, which function prime is e to y, and plus a constant c. Which function prime is e to y. This is the easiest function of all, is e to y. But I have to replace y by negative t squared. So this is negative 1/2 e to negative t squared plus a constant c. And this is it.